Okay, so Assalamualaikum and hi. So today we are from group 10. So we're going to present our coding, which is by using a Phyton language. And firstly, our team chose Maternal Health as one of our group project names. And for the Maternal Health data sets, we do have like 1014 data sets, and we choose 304, 30% of the data set. Okay, so first for the coding, we download the compiler, which is pip install sccat fuzzy, and next we do a library that import matpilot and define some things. And next we do declare a variable, which is systolic, dystolic, and also a risk. So for the next is we create a fuzzy logic membership graph by using a systolic. For the systolic, we do have 3 levels, which is low, normal, and high. And for the data set, we do put a data set that consists 30% of the data sets. And this graph will generate a the graph. Okay, so this is the graph of systolic BP. As you can see, it will intercepts, and yeah, the low will intercept with the normal, and the normal will intercept with the normal, with the low and high will intercept with the normals. So for the next is diastolic, and diastolic also have 3 levels, which is low, normal, and high. And for the diastolic graph, it's kind of same with a systolic, which is the normal we intercept with the low and high, and the low we intercept with the normals, and the high we intercept with the high. So last for our variables is our output, which is risk. We need to find the risk level of people get with the moms with maternals get that, which is have 3 levels: mid, low, and high. So it's kind of same. I mean the graph kind of same. It intercept with the normals. And I think after we we create the variable, the input variable and output variable graph. Atas sikit. We do create a rule for our attributes and for our memberships. And after defines the rule, we do create a fuzzy system that will declare the rule itself. And next, I will pass the presentation to Nurliana.
Okay, first thing, when we want to read the input from files, we need to initialize an empty list to store the result. And in this case, we will use the result list to store it. It will iterate over each row in the data frame from our files, which is the 30% files here. And then it will calculate the input. It will calculate the input using the risk simulation dot compute. After that, it will compare the result. If the Chris output is under or the same as 40, you will generate the risk level mid. If the Chris output is less than or equal 75, it will generate low, and if it's not, then it will generate high. The output will be added to a new column in the updated in the updated Excel file, which is named 30% data output. And here we can see that the data output, it will be like this. Then to find accuracy, we just use a comparison method if the original data is the same with the risk level, the output level, the output, it will generate the accuracy as 1. If it's not, then it will generate as 0. So after we find everything that has the input that have the value 1, we can see that the accuracy is 186 over 305, which will generate a 60%, 60.98% accuracy. And that's all. Thank you.